Hello everyone. Today we will continue to look at a topic in HCI cloud computing. Previously, we have already introduced the history of computer development, and next we will move on to the history of virtualization. Virtualization, in fact, is a very important part of our budget. Basically our underlying layer, the underlying layer of cloud computing, is built using virtualization. So here, we must definitely understand virtualization. First, let's introduce what virtualization is. The meaning of virtualization is actually quite broad. It is not just a single definition. Here, virtualization actually refers to abstracting any form of resource into another form. Virtualization of resources is essentially changing the form of representation, turning our physical resources into into a logical representation, and that is our virtualization. So, what about virtualization? Actually, it is a foundation of our cloud computing. Simply put, virtualization allows each of our servers to run many virtual machines. Normally, in the traditional sense, we would typically deploy one, or a few services on a single physical server. But now, through virtualization, a single server can run multiple virtual machines simultaneously. These virtual machines share the CPU, memory, disk, and other resources of the physical machine. Moreover, logically, the virtual machines are isolated from each other, meaning they have no relation to one another. Each virtual machine is an independent entity. This is a fundamental aspect of virtualization. In terms of computing, virtualization generally involves abstracting the physical resources of a computer to provide one or more virtual environments, thereby enabling resource emulation and sharing. Essentially, virtualization involves a software module at a lower layer, providing an interface to the upper layer software module that is completely consistent with the originally expected operating environment. It abstracts a virtual software or hardware interface, allowing the upper layer software to run directly in the virtual environment. This is achieved through spatial partitioning, time sharing, and so on. Simulation. Virtualization can abstract a single resource into multiple resources or multiple resources into a single one. Both are possible. Here, virtualization essentially creates an isolation layer that can completely separate the hardware, including our upper layer applications. It allows multiple logical applications to run on a single hardware resource. In the simplest terms, it can be summarized as improving our resource utilization. You see, under normal circumstances, on one server, you might install one or two services. What will it definitely have? CPU, memory, and hard drive will definitely have some redundant space. Moreover, if your service, let's say the content it runs or the business it handles, isn't particularly extensive, then the idle space might be very large. In such cases, it's actually a waste of resources. So if I turn this physical server into a form of virtualization, we can install 10 or 20 virtual machines on this one server. In this way, what can we do with the resources of the entire server? We can fully utilize them. Of course, when the resource usage reaches about 80%, you can actually leave the remaining 20% as a buffer, It's enough to leave some margin and not use too much. In this way, an 80% utilization rate is actually very high. You see, with normal physical servers, if you install one or two services, the utilization rate might only be around 20, 30%, or 30 to 40%. So the efficiency is not particularly high. This is actually one of the benefits of virtualization. Next, let's take a closer look at virtualization. The development history of it. Initially, in the 1960s, it was IBM again. IBM can be said to be... Basically, it was the most important company in the early development of computers. In the 1960s, IBM developed a software called the Blue Giant, which was essentially used to implement virtualization on mainframes. By 1972, at this time, they had already directly named our CCT, our 370 extension as what? Named it our virtual machine. At this point, the virtual machine was officially created, essentially starting from 1972. At this time, another system was also born in the 1970s. In 1972, this virtual machine began to be used, and then later on. Gradually developing to 1999, the virtualization software VMware, which we use quite a lot now, was also born. As for VMware, it was initially a virtualization product that could run on our x86 architecture, a virtualization product that runs. In 2002, this was the birth of XN. It successively released versions 1.0 and 2.0. Initially, it was applied to the Red Hat Linux distribution and others. Subsequently, an engineer from Intel began to add hardware virtualization support for XN. And later on, by 2005, Intel's virtualization technology could officially start supporting virtual machines. It officially began supporting virtual machines. Then in 2006, the KVM software was also born. These are some of the virtualization software that we commonly use today, and you might have heard of one or two of them. Nowadays, it's like a silent understanding. Actually, it's quite widely used now, especially this thing. It's used in many of our clouds. The underlying layer of many cloud services uses KVM as the virtualization base. Many use KVM as the virtualization base. Then, on top of that, they build a management platform to uniformly manage our virtual machines. Many are done using KVM. KVM appeared in 2006, right? It's been almost 20 years now. It is still very much in use today. Its application is still very widespread indeed. Since 2006, you can see we've listed many years like 2006, 2007, 2008. During these years, in a way, many virtualization products emerged, a great many. For example, Microsoft launched Hyper-V. Then by 2010, the RHEL RH16 system appeared. Or rather, the RH16 system. At that time, it had already integrated the latest KVM virtual machine. And subsequently, including up to now, many of our Linux distributions, especially the Red Hat series, have integrated it. Therefore, the overall installation and deployment are very convenient. Then moving forward, by 2020. In that year, several companies had already established a virtualization alliance, starting to promote KVM as a whole. Nowadays, KVM is relatively widely used in cloud computing as a virtualization method. By 2013, Docker appeared, which is our container. It can actually be considered a form of virtualization. However, it does have certain differences from the virtualization methods we mentioned earlier. Then moving forward to 2014 and up to now, actually, virtualization products have become more numerous and diverse. Overall, to summarize the use of virtualization products, if you are directly using virtualization within a company, or if you want to directly use virtualization, if you're only using virtualization without implementing cloud solutions, what can you consider? You can consider enterprise-level virtualization, which has been around for many years and is a very mature software. If later on we are dealing with cloud-related content, what can we consider? We can consider our virtualization, which is more suitable for deployment in cloud environments. At that time. So this is the overall development process of virtualization. Currently, the more common types of virtualization mainly include VMware and KVM, because typically, the systems used in servers are primarily based on Linux systems. Therefore, the virtualization used within Linux systems is also the mainstream virtualization. Here's the overall development process of our informatization. That's all for today. If anyone wants to learn about Huawei cognitive technology or obtain Huawei certification question banks, please send me a private message, or you can leave a comment below the video for technical exchanges. That's all for today.